two quick integrals here, one indefinite integral and one definite integral, and two different techniques to solve them. So the first one, we can see it's essentially a polynomial other than the square root, but we can just make that into an exponent, and then we're really comfortable with integrating terms or taking the antiderivative of terms when they're just following the power rule. So let's see how we do that for part A. So 4t cubed, so all we have to do is go up one power, so it's t to the 4, and that 4 in front comes along, and then you divide by the new power. So those just cancel, and it'll be t to the 4. You can always check if you're doing integration right by actually taking the derivative. So the derivative of t to the 4 is 4t cubed, which gets you exactly back to where you want to be. So that's a good check. So t to the 4 is the first term. I'm going to rewrite this one under here. So it's minus 2t to the power of 1/2. Power of 1/2 is the same as square root of t. So to go up 1, so the minus 2 comes along, we're going to t to the 3 over 2. That's 1 up from 1/2. And we're going to divide by 3 over 2. That can simplify later, but we'll do that after. Plus 1, that must have come from plus t. And then we always, for indefinite integrals, include plus c, because there could be a constant on the end that doesn't actually change the impact of the differentiation if we were to try and get back to the function inside the integral. So just cleaning this up, it's t to the 4 minus 4 over 3 t to the 3 over 2 plus t plus c. Great, so that's part A. Let's look at part B. Part B is a little bit trickier. We have x's in the bottom, x is on top, and it's a definite integral. When we have x's of different powers, we have to use one of our techniques. So we should be able to see that because the power is 1 greater in the bottom, and that's raised to an exponent, we could probably use the substitution rule, where u equals whatever's in that bracket. So I'm going to call u equals x squared minus 10. Differentiate, du equals 2x dx. Great, so now if we're looking at the integral we have, 0 to 3 of 5x dx over x squared minus 10 to the 3. This just becomes 0 to 3 of, if we want 2x dx and we have 5x dx, that's just 5 over 2 times du. Right, because your 2's would cancel and you'd be left with 5x dx over u cubed, which is the same as the 5 over 2 can just come out front. 0 to 3 of u to the power of negative 3 du. Now, that's the whole reason why we use substitution, because now it's super easy to integrate. U to the negative 3, you go up 1 power, so careful that up 1 from negative 3 is u to the negative 2, and divide by that new power. We still have our 5 over 2 out front, and this is going to be evaluated from 0 to 3. Only you have to be very careful that you're not going to evaluate u from 0 to 3. We need to substitute back in our x value. So I'll do that in red over here. So we've got 5 over 2. Instead of u, we called that x squared minus 10. So it was 1 over negative 2 x squared minus 10 to the 2. I put it on the bottom because the exponent was negative 2, and we're going to evaluate that from 0 to 3. So now it just becomes 5 over negative 4. I'm just taking all the constants out to the front. You plug in the 3 first, and you get 9 minus 10, which is negative 1 squared, so it's 1, minus, plug in 0, and it's 1 over 100. And that is your answer. So it equals 5 over negative 4 times 1 minus 1 over 100 is 99 over 100. And you can multiply that out. So two different types. Definite, because we saw the limits here. Indefinite, because there were no limits. Get everything in terms of powers if you can, and then it's an easy integral for like part A. Part B, you have to notice that you have different powers of x's, so your substitution rule comes in real handy. Hope that was helpful. You can always send us more at info@arnoldtutoring.com. Thanks.